In the last video, I was able to get the initial interrupt working, and basically with that, as I would press a key on the keyboard, the interrupt controller would recognize that, pass that on to the processor, and then the processor was running the interrupt service routine that I had that would write out to the LCD. And as I pressed a key, that actually generated 3 interrupts, 1 for the key down and 2 for the key up. And I'll talk more about that later. But then all 3 of those were coming through, and for each one it was putting an exclamation point out to the screen. And that was working. Now in this video, I'm going to continue with what is some of the assembly to actually get this keyboard to work a little bit better than, so we're not just throwing exclamation points out to the screen. So at this point, if I turn the system on, you're going to see that I bring it up to a caret prompt here, or greater than a little prompt, but I can type and it is processing just fine. I can escape and clear the screen and basically work through this. So far that seems to be working out quite well. And I'm going to walk through the code of what I have so far, and some of it is, I want to call it interim code. It's working. I know it's working the way it is, but there's a better way to do some of this stuff, and I'll talk about that a little bit. But rather than having one video that just builds too much into a single sitting, I'm going to break this up into chunks. So this first chunk is how did I get to this basic functionality, and then maybe a later video I can dive deeper into having cleaned it up a bit. A little bit more proper implementation, but at least this is enough to kind of get going. So on my screen, what you're seeing is basically the code that I have at this point. And in the last video, I had kind of stubbed in this interrupt service routine for the keyboard. And if I scroll down through this, I am going to actually jump to that code. And I have this keyboard interrupt service routine right here. So when I press a key, like a Q, I get the Q on my screen. I also see the scan code for the Q here. And I've also filtered out all of those extra pulses that come from the key up. So it's just the key down that iterates and runs that Q. The Q key up does not generate another, well, it generates the interrupts, but I'm filtering them out, so I'm not doing anything with those. And so let me walk through the code that I have here and kind of give you an idea of how this is working. So the first thing I do when I get into my interrupt service routine is I actually disable interrupts. Later I might change that, but for now I'm just kind of saying if I'm in an interrupt, stop taking additional requests for more interrupts. I think with this setup I can do better than that in the future, but that's what I want to start with here. Keep it simple. Then I push everything, all of my registers and such, off to the stack so that I can retrieve them at the end of this. And then I get into some code, and I created a flags variable. So if I come up here, there is this keyboard flags. And that is here in this section that I'm calling .data. And so I'm going to use that along with different bits. And the first bit I'm going to use, at least in this code, is the far right bit. I'll call it bit 0 here. And if I set it to a 1, that tells me that I've already pressed a key and the next thing to happen is a release. So that's just a flag that helps me track that. And in this service routine, then the first thing I'm doing is checking to see, have I already pressed the key down, and I'm waiting for that release. And if it does happen to be that it is the release that's happening, I'm essentially saying don't do some of the following processing. So I grab that, I AND it with the release bit, which is the far right bit. And if the flag was set, that's going to come back with a 1. And if I say jump if equal, that's saying like jump if it's equal to 0. In other words, it came back with 0, meaning it's not set. Then I'm going to move forward and actually read out the scan code that's over here. If it was a release of a key, then I'm going to continue with this code. And then I basically read the flag, I toggle the release bit, and I write it back. So I read my keyboard flags, turn off this because I've now done the release. And then I jump down to a further section at the end of, I skip all of this code basically and say, okay, that's a non-ASCII. Go ahead and get out of this interrupt now. So that's kind of what I'm running through for my up of a key. Now, if it wasn't an up, then it's going to have jumped to a read. And at that point, I call a procedure that says, go get the scan code. And that's just PPI number 2 that I'm accessing. So for PPI number 2, I ended up putting in a couple of things here. First of all, if I come up, I added, let's see, where is it at? Right here. I added an additional just configuration up here. So for the LCD, we had used this PA in and out and set these bits accordingly to configure the PPI. Now in this case, I'm using a different PPI, but I'm making a different configuration for it. And really the thing to point out is this second to last bit for PB, I'm saying is an input. So I want to read in on the port B of whichever PPI I assign this configuration to. And I'm going to scroll down, and I apologize for all the scrolling back and forth, but a little bit of a necessity here. So then I'm going to find a procedure that gets me my scan code, and here is that procedure. Basically it says I want to use that configuration I was just looking at, and I'm going to write it out to PPI2 control port, and then I'm going to go out and get PPI2 port B, and I'm going to read in whatever's on that. And what it should always read in is what you're seeing here. So if I hit a Q, that is the scan code for a Q, which happens to be a hex 15. So there's my hex 15, there's a W, an E, R, T, Y, and you can see what all the different scan codes are for those. So all I'm doing in this procedure is fetching that scan code. And then that brings it back out as my lower byte of my A register. So then if I go back up, I've done my read basically of the scan code. I now have it in my lower A. Then I do some filtering, and I first look to see if the scan code was a 7E. There's something about this Microsoft Ergo keyboard. When I turn it on, there's an initialization sequence, and it sends a few 7Es. I don't want to do anything with those. Those are not scan codes I'm going to use later at any point. And I don't know exactly what they are, but there's something about the initialization of this keyboard. So I just say if it's a 7E, jump down to this non-ASCII, basically get out of this whole interrupt. If it is not a 7E, then I continue on to this next check. And that's where I'm checking, am I doing a release key? And a release will come through as an F0. So when I press Q down, I'm going to receive a 15. And when I let it up, I'm going to receive an F0 and then a 15, which says you're releasing the following key. So 15, I hit a Q, and then I will follow that with a second interrupt, which is a release. Third interrupt is another 15. So I'm basically saying check if I'm doing a release. And if I am doing a release, then I want to process some stuff. If I'm not doing a release, I want to jump to my next check. And if I do a release, basically then I'm going to go ahead and set this release flag. And basically, so jump if not equal. So I'm going to go out and I'm going to look and say, does this key, this key scan code, does it basically match an F0? And if it does not, jump down here. If it is an F0, then I've got some processing to do. So load up my flags. I'm going to then OR it with the release, which is setting the flag. So I press down. As I come up, I'm saying, oh, you're a release notifier, an F0. Flag it that I'm now in the middle of a release, which then means that next time I come into this interrupt, it's going to say, oh, you're in the middle of a release. Don't do anything further with that queue that you're going to receive the next 15-year release. So basically, this is just the logic that's toggling and letting me know, am I pressing down or coming up? And if I'm coming up, don't do anything with that key. Just do it on the way down. I then get to this escape. I look for the escape key. And that's so that if I press this, I want it to clear the screen like you saw there. And so in my case, I am going to call a procedure called LCD clear. A really simple procedure. And I think I've got that down here. It basically just sends a 1 as a command to the LCD. And so this was a procedure I talked about in the LCD videos that I did. And then this is the actual command that will do a clear. So that's pretty easy. Then I come back up here and I then say, okay, you've cleared the screen. Now jump down to this not ASCII because it's not an ASCII character I want to print. I probably have a whole bunch of other work I need to do in here to check for other characters, like an arrow. What if I hit a left arrow? So I just need to put in all of those checks and what to do when I hit a left arrow, right arrow, up, down, whatever. The only one I put in so far is escape. I'll probably put in enter next, which will take it to the next line on the LCD. That would be an easy one to work with. But then later I do know I want all my numeric keypad, I want the up and down arrows, I want my function keys to do stuff. I just have to put in all those checks. And then if it makes it through that, up to this point, I'm actually into this ASCII. And what I do is I have a test procedure that I put in here to call print char hex. So I made a procedure that will take this value that it gets, which is a scan code. It's not an ASCII value. It's a scan code. But then what I'm going to do is I want to print that scan code to the LCD, which means I've got to convert some hex number into ASCII values that I can represent that scan code in hex on my screen. And this procedure that I have in here, print char hex, does that. And here is what that code looks like. It's basically just saying, for example, if I had a byte value of, let's just say a 1, this is going to then print X01 on the screen. And it's not going to try to treat it as an ASCII one, which would not be anything that you'd be able to visualize. So that's all this procedure does. And it basically has to look at that scan code nibble by nibble. So the top 4 bits it processes, and then the bottom 4 bits it processes, and it does a conversion from basically that, I'll just call it a byte or a nibble of data into an ASCII value. And that's working pretty well for me. Right now I've got it commented out because once I got it working, I now know I can press a key and get the right output. I didn't need to see that hex data. But later, if I want to get in, for example, and start hitting a left arrow, and I'm trying to figure out, well, what is that key code, the key scan code, without looking it up, or if I'm getting something that doesn't match what my online references say I should get for scan codes, then I can actually test it. What am I really getting for a scan code? Now here I am going to say call this scan code to ASCII, and so that's a procedure down here that basically takes the scan code. Let's say I hit a Q, I get a 15 hex. I've got to turn that into the actual ASCII value for a Q, whatever that ASCII value is, 70 something in hex. So this will do that. And now to do this, I had to put in these procedures, 2 ROM and 2 RAM. And someone, please tell me what the better way to do this. I'm sure there is a better way. But right now, to do this conversion, I am using a key map. And so down here, you can see I have this key map. So if I get a Q, and that is a hex 15, which means it is going to be 1 row down and 5 over on this. There's my Q. All I'm doing is I'm going to say go to key map and then offset it or index into it by the value of the scan code. And then that will show me what the ASCII character is that corresponds to that scan code. And so that's what all this data is. It's just a conversion. If you see a question mark, it's either it's not a valid thing or it's something I don't care about. This is stuff I had pulled way back on Ben Eater's 6502 stuff. He had created this, and maybe I've tweaked it a little bit, but it's pretty close to what he would have provided. I'm just putting it into an x86 now instead of a 6502 set of assembly. But that's that key map. Now this is in my ROM, and so in this conversion, I'm calling a procedure to ROM that basically just changes my data segment to match my code segment, which is in ROM, so that when I go to reference key map, it gets to it okay. And then when I'm done with that, I go back to RAM where I say, take my data segment and go back to the beginning of my RAM. That's how I'm getting to this from this code and using really 0 as the base of my RAM. If there's a better way to do that, please let me know, but this is how my brain is making sense of this for now. So then from there, I continue, and as I look at this, then basically I do AND it, so just in case this comes in, it seemed like, and again, this is me maybe not knowing the assembly well enough, I could only do this type of indexing or offsetting with the full register. I couldn't do it with a BL, and if I tried doing it with a BL, I would get this invalid effective address when I try to assemble. So up here I do an AND just to make sure I'm only looking at the lower byte, and then after I pull back this, I'm actually probably pulling back, I would assume this is pulling back 2 bytes, and I'm really then saying I only want to look at the lower byte, and then basically I get out of this procedure. If I come back up to my code then, so I would have now gone out and converted my scan code to ASCII, and then I print that ASCII to the LCD, and that print char is the same as what I had before, where it sends it out to PPI number 1. And then I re-enable interrupts and I get out. And so part of this is I had to send this 20, hex 20 to this E, or what they call an EOI, out to this P0 of my PIC. And so that gets sent here. But re-enable my interrupts. I put all my registers back to where they were before I came into this. And then I return out of this interrupt back to whatever code called it, or whatever code was running when it got interrupted, which in my case would be just this loop code. It would jump back to that. So I think that is it. And maybe some other commentary I would add here. Right now, I'm doing all of this in the keyboard ISR, the interrupt service routine. That's not a good place to have this. I will update this so that when the interrupt happens, I'm just going to simply go right into a buffer. I receive this scan code, and then I'm going to kick out of the interrupt. And then maybe in the main loop, I'll just constantly check that buffer. Is there something new I should be processing? And then as I see it, then I'll print it out to the screen. This code right now, I mean, it runs very well. It keeps up with anything I do. I'm running an effective clock of 5 megahertz right now on the processor. But later, when I get more stuff going on, maybe I'm playing back some music, or I'm doing some video processing, whatever it might be, to render out to a VGA screen, I don't want this to take long, especially if there's going to be back-to-back interrupts happening or other things that are going to interrupt my system. So I will change this eventually here so that this interrupt routine, all it does is it throws in, here is a sequence of key code, scan code that I've got to do something with, and then get out of the interrupt, and then let that other stuff happen during normal processing. Let's see if there's any other procedures I have in here. I think those are the big ones. So I've got the hex printing, I've got the get scan code, I've got a conversion from scan code to ASCII, and then I'm using this to ROM and to RAM to kind of flip back and forth in my memory from RAM to ROM, where I want to be reading things from my data segment. I added an LCD clear. I'll add an LCD return or LCD enter or key enter type of thing here. But that's pretty much the code. So that's a quick walkthrough of what that's looking like so far. I'll continue to improve this and clean it up and move things out of the ISR into a separate, just normal loop type thing. So that's one thing I've got to do. And there's some additional flags I'm going to track on the keyboard. In this KB flags, you can see that up higher, I've got also one to tell me if I'm shifting. So right now, my shift does not work. See, if as I press shift, I'm getting a question mark. That's one of those that I have to process and say, oh, if you press the shift, I need to toggle a flag. And then when you go to read out from that table below, there's a shifted table, and that's all the same things. It's just whatever I want as a shift. So if I do a shift and a 15 hex, I'll get back a capital Q. I just have not put that functionality in yet, but that would happen up here. I would check for the shift key, set that flag accordingly, and then when I go to actually look up the ASCII value, if the shift key is set, I'll return the shifted version of the Q instead of the non-shifted. So that's it for now. More to come on this later. I think I'll just clean up some of that little by little as I go, and maybe at some point if I get it more complete, I'll just post an update and have that code available if anybody wants to go look at it. I think the next thing I'm probably going to get into is the math coprocessor. So I think the next video will be just getting that wired up, and maybe the video after that will be to see if I can actually use the math coprocessor and have it do some sort of a calculation, maybe some floating point multiplication or something like that. I think I'm sitting at a pretty good point. I actually have some real input working. I have some real output working. I can't control any processing like calculations or anything yet, but if I get my math coprocessor put in place, then maybe I can write a program that'll let me enter in a decimal number, a second decimal number, and have it multiply and show me the result. That would be another good milestone in this project. So as always, thanks for watching, and more to come.